Hello everyone. Today in this video tutorial I will be taking care of a new light sensor, a color sensor specifically, and it's a BH1745NUC. And to gain more knowledge about this sensor, let's have a look over the controleverything.com, and here we have to search for this particular sensor and let's see what we got for it. As you can see, it's a digital ambient light and color sensor, and also it's the sum of features which are described clearly on this screen. You can have the sensor, you can purchase the sensor from here also. Well, I will be interfacing the digital ambient light and color sensor BH1745NUC with a particle photon, and I will be requiring a particle code, and here we go. As you can see, you can also have the code from this website. You can download as a zip file. You can also have the code from github.com, and the repository there is control everything community. Now let's have a look over the hardware connections we would like to set up, and let's move forward. For the hardware connections part, first of all, the requirement is of our digital ambient light and color sensor, that is BH1745NUC. And now what we require is a particle photon, which you are able to see on my screen. Now this here is an I2C Shield. This shield is available on the website controleverything.com, and the real reason we are using it is to make easy connections with other I2C devices. So gently place over the particle photon over the I2C shield and make a connection. Now this here is a connecting cable. Now this is very useful in making connections with the sensor and the shield, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and for the same reason to the I2C shield. Now the last part is to provide the power. So for that we require a micro USB cable just like that, and we are done. Now gently put it over the power jack. So we are done with the connections part. Now what do we require is to have a look over the code, and let's see what we got there. Now what do we require is to have a look over the code, and to get the code we have to log into github.com, and here we have to search for the repository. As you can see, it's control everything community. Now there you go, and here we have to search for the sensor, that is BH1745NUC, and this here is our particle code. But let's have a look over the instructions to fulfill. As you can see, we have to log into a particle photon and set up the device according to the steps, and the steps are being provided on this very link. Let's open up this link and see what we got here. As you can see, all the relevant information to connect to set up the device are there. Please follow it carefully. After that, we have to download the code, and on the online ID we have to copy the code, and build.particle is the online ID where we have to create a new file, and the code is there. As you can see, you can save the code there. The last part is here. As you can see, we have to verify and flash the code on the particle photon, and the code output will be shown in the form of logs at the dashboard, and this dashboard.particle link is there, user logs, where we can have the relevant data, as you can see. Now get back to the code for the further clarification. As you can see, it's a .ini extension file. Now in the code, please notice that we have included two header files. As you can see, application.h and spark wiring I2C.h, and we have the address of the sensor, that is 0x38. We have initialized some variables here and created some variables here for particle.variable. Now in the void setter function, we have initialized I2C communication and serial communication with the baud rate equal to 9600. Now coming to the writing part, where we are sending commands to the sensor, it says that we are selecting the mode control register 1 having address 0x41, and we are sending the command to set RGBC measurement time, that is 160 millisecond. The next command is to select the mode control register having address 0x42, and the command here we are sending is to set measurement mode active and gain is 1x. As you can see, it's 0x90. In the third command, we are selecting mode control register 3, that is 0x44, and the command here we are sending is to for the default value, that is 0x02. Now after that, we have a delay of 300 millisecond, and then we have a void loop function, and here we are selecting the data register from which we are going to read, and it's 80 plus I. Now here from this very loop, as you can see, we have a for loop which run 8 times, and from this we are requesting and reading 8 bytes of RGBC data, as you can see, and after that we have the conversion of the data takes place, which is according to the guidelines provided in the data sheet for BH1745NUC. At the very end of our code, after so much of calculations, we want to display the output on the dashboard, which you can see is RGBC color luminance, which is lux unit is there, and the luminance will be displayed. So this is a very simple and generalized code. As you can see, now what do we require is to have a look over the working, the practicality of this code along with the particle photon. Let's have it. Now for the working part, what do we require is to, first step is to copy this entire particle code as you can see on my screen. Then open up the build terminal as we have discussed in the instructions part, and here we have to create a new file, and for that we have to paste the entire code, and here we have to name the sensor, that is BH1745NUC for the reference, and then save it. And after that we have to verify and compile the code, and then we have to flash the code. While flashing the code, we have to check for the magenta flash, which will confirm that code is good to go. And as you can see, we have the successful flash and the notification is there, just like that. Now what do we require is to open up the dashboard link and see what we got on the user logs, and there you go. As you can see, you have the values regarding the RGBC, that's red, green, blue and clear data luminance. The unit is lux, and the values are almost constant because there is no interference regarding the light intensity that is falling on the sensor. Now, but when I place some object over the sensor, you can see the change regarding the RGBC value. It's decreasing continuously as I'm moving the object too close to the sensor. There you go. But instead, when I bring a light source on near the sensor, you can see the increase in the RGBC value. That's correct. As I move the light source near the sensor more, you can see there is much increase in the RGBC value. That's correct. Now this here is the working of the sensor BH1745NUC. It's an ambient light and color sensor. Now what do we require is to have a look over the benefits and the applications of the sensor. Let's have it. BH1745NUC is a digital color sensor IC with I2C bus interface. This IC senses red, green and blue light RGB and converts them to digital values. The high sensitivity, wide dynamic range and excellent circuit characteristics make this IC the most suitable to obtain the illuminance and color temperature of ambient for adjusting LCD backlight of TV, mobile phone, Note PC, tablet PC, portable game machine, PDA and LCD display. This sensor is available on the website controleverything.com, and you can purchase the sensor from there. You can have the code from the resource tab, and after that you can download the code as a zip file. You can also have the code from github.com, and the repository there is Control Everything Community. In the end, I would like to clear everything, and for further queries you can have a look over controleverything.com. You can contact us there, and also for comments you can post your comments on community page. For articles and blogs which are relevant to this sensor and video, you can go to instructables.com, and to subscribe more video tutorials like this you can have a look over our YouTube channel. I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.